Okay, in problem 2, you're asked to write the equation of the circle that has center at 2, 5 and has radius of square root of 5. So I write down the general form of a circle. I replace h and k with 2 and 5 respectively. I plug in square root of 5 for my radius. It gets squared and simplifies out to be 5. So there's my finished product right there. In number 6, we're given this equation, and we're told that it's the equation of a circle, and we're asked to find the center and the radius. So I have to think of these as subtractions inside the parentheses here. So x plus 1, I think of that as x minus negative 1, quantity squared, and then y minus 1 quantity squared, nothing to change there. I think of 1 as 1 squared. So I see that h is negative 1, k is positive 1, r is 1. So the center occurs at negative 1, 1. Now let's look at example 4. We're asked to write this equation in standard form for a circle. And they do a whole bunch of algebra, and they get it to look like this. So, oh yeah, h is negative 2, k is positive 3, r is 4, because 4 squared equals 16. But I want to emphasize looking at this going in the other direction. If you have the equation of a circle and you multiply everything out in group-like terms, so on and so forth, you're always going to end up with something of this form. An x squared term, a y squared term, an x term, and a y term possibly, and then a constant. So, someplace I have it, here it is, it's already up here. I see how this matches up with my conic section in general form. Playing the role of A is my invisible 1, playing the role of B is 0. Right? There is no xy term. Put the dash where it belongs. Playing the role of C, the invisible 1. Playing the role of D is 4. Playing the role of E is minus 6. Playing the role of F, minus 3. Okay. So you see what makes a circle. When you look at all the terms, you're going to have an x squared term, you're going to have a y squared term. You might have a x term, you might have a y term. And A equals C, right? The coefficient of the x squared term matches the coefficient of the y squared term. That's what tells you it's going to be a circle when you go ahead and graph it. All right, now that we're experts on circles, let's look at parabolas. On page 645, they start talking about parabolas. Now we already know quite a bit about parabolas. We know that a quadratic function has a graph, which is a parabola. And we know that a quadratic function follows this general form, where a is not 0, because that guarantees that we're going to have an x squared term. And this is a function, in fact. If we regard x as our independent variable, which we normally do, and y as our dependent variable, you'll notice that in the text they show you this alternate form for a parabola. Oops. Parabolas can be written like this, where P is a number that indicates the focus of the parabola. And the focus is shown in the diagrams in the book. We're not going to cover that. And then from the focus, if you have the line on the other side of the parabola, it's called the directrix. And it tells you lots of other information about parabolas, but we're not concerned with that today. Let's look at example 6. On page 646, we're asked to graph the parabola y squared plus 4x minus 6y plus 5 equals 0. Okay, the first thing you notice is it's the y that's being squared, not the x. So this is not going to be a function. This is going to be a parabola that's lying on its side. And it's going to fail the vertical line test, so it's not a function. Well, let's go ahead and look at that graph. Okay, it's actually just a little bit north of the origin there, where it goes through, and it's not a function, fails the vertical line test. It's a parabola lying on its side. We could make it look in this form if we reverse the x's and the y's, right? We could make it look like that. Notice what you don't see. As with the circle, there is no xy term. But different from the circle, there's no x squared term. Let's look at this general form again. Right? We've got a y squared term. We don't have the x squared term. We don't have the xy term. We have an x term. We have a y term. We have a constant term. Okay, so that's your clue for identifying the equation of a parabola. One of the squared terms is going to be missing. If the y squared appears, then you've got a parabola lying on its side. If the y squared is gone and the x squared is there, then it's a parabola that opens upward or opens downwards. In other words, vertically aligned. And of course, the xy term is missing. Now, can you tell the difference? Let me give you these equations to look at. In part A of this problem, I have this equation, x squared plus y squared plus 4x minus 2y equals 0. And I'm going to tell you it's either a parabola or a circle. In part B, my equation is x squared plus 10x plus 8y plus 49 equals 0. Again, it's either a parabola or a circle. So I want you to go ahead and classify each of these. All right, let's see which figured out. I notice there's both an x squared and a y squared. So this has to be a circle. I told you it was going to be one or the other, so it has to be a circle because I know it's not a parabola. In fact, there is no xy term, so that's not in there gumming anything up. All the other terms are legal. It's a circle. And notice also, by the way, that A does equal C as we compare it to general form. How about B? Is there an x squared term? Yes. Is there a y squared term? No. So therefore it can't be a circle. So in this case, since I told you it was one or the other, it's got to be a parabola. And we can see, yeah, there's no xy term, everything is legal, so yeah, this is a parabola. It's a parabola that's vertically aligned because there's no y squared, there's only the x squared. So for homework, first look at this MML video I have for you, 8.7 video, that's pretty educational. Then on page 647, do 1 through 9 odd.